Okay. So now biasing circuits, everything is completely done. And now we are going to focus on the H parameter model of BJT. Okay, so the S parameter model, we have already seen this in our, you should have studied this in the electron devices subject. So we have seen the H parameter model of BJT, right? So this is low frequency model. High frequency, we have the hybrid pi model. I think you should remember the things which you have studied in devices. So those things only we are going to completely rely upon in H parameter model of BJT. So H parameter comes from the name. It is hybrid parameters. Hybrid means one side you are going to have voltage source, one side you are going to have current source. Equation also you see, one side you will have voltage equal to some equation, one side you will have current equal to some equation. See, it is all used to represent a two-port network. Two-port network means it is going to have two ports, where one port is going to act like an input port, one port is going to act like the output port. So here V1 is the input port, V2 is the output port, I1 is the input current, I2 is the output current. And the one general rule is all the currents are assumed to flow towards the network. So I1 will be flowing towards the network, I2 will also be flowing towards the network. And in the input side, you will have resistance in series with voltage source. In the output side, you will have current source parallel to the resistance. So whenever you know a current source will have coming, you will be drawing a resistance in parallel, right? So same way, whenever you have an voltage source, you will be drawing a resistance in series. So remember it like that. In the input side, you will have voltage source series with resistance. In the output side, you will have current source parallel to the resistance. And if you write the equation, you can write V1 equal to I1 into I1 into HI plus HR into V2. This HR into V2 is going to oppose V1. It is going to oppose V1. Okay, and I2 is splitting up into two currents. I2 equal to one current is HF into I1, the other current is V2 H naught. Okay, these are the two equations, H parameters we are going to have for the transistor model. Generally, any circuit we are going to have these two things, and we are going to use this for transistor. Can anybody recollect and say what did I say? HI. What is HI in a transistor? What is HI represented here in the H parameter model? We have studied this in electron devices, the hybrid H parameter model of a common emitter BJT. So what is HI referring to? HI refers to what? Nobody is remembering that. HI refers to what? HI, HR, HF, and H naught. We have four parameters, right? What are those parameters representing? Sai Krishna, you know the answer? Sai Krishna, you are there? Sarvesh? Nobody is there in the class?
Sir, input, sir.
No, HI, what is the name for HI? I told you all these parameters have specific names. And I have told you that also in devices class. You should have written exam also. You should be knowing what is HI. HI is input impedance. Did I not say this in the class? HI is input impedance. H naught is output admittance. HR is reverse voltage gain. HF is forward current gain. So these four parameters will be represented from the H parameter model. So from these two equations for V1 and I2, they are related by the four parameters HI, HR, HF, and H naught. I once again say HI is input impedance. At the input side, what is the total resistance or impedance you have? HR is the reverse voltage gain. Usually, voltage gain is output by input. Reverse voltage gain means input by output voltage. HF is forward current gain. Current gain means output current by input current. H naught is output admittance. Admittance means it is going to be ohm inverse. Okay, so remember, for any amplifier, we'll be finding out these four parameters: HI, HR, HF, and H naught. So hereafter, we are going to focus only on the common emitter configuration of BJT strictly. We are going to consider that as an amplifier, and we are going to find the expression for all the four H parameters.